pair of straight lines. If suppose the second degree general equation ax square plus 2hx5 plus by square equals to 0. The second degree homogeneous equation ax square plus 2hx5 plus by square equals to 0. Homogeneous equation. If suppose for example f of x comma y equals to 0. The given equation f of x comma y equals to 0. Now if suppose f of kx comma ky equals to k to the power of n into f of x comma y, k to the power of n into f of x comma y, then f of x comma y is said to be nth degree homogeneous equation in terms of x and y. If suppose for example f of x comma y equals to ax square plus 2hx5 plus by square equals to 0, then f of kx comma ky equals to a into k square x square plus 2h into kx into ky plus b into k square y square equals to 0. Now that equals to, in all the terms k square is taken common, we get ax square plus 2hx5 plus by square equals to 0. Yet the exponent of k is 2, then the equation ax square plus 2hx5 plus by square equals to 0 is second degree homogeneous equation in terms of x and y. Similarly, if suppose here the exponent of k is n, then nth degree homogeneous function. If suppose the pair of lines ax square plus 2hx5 plus by square equals to 0, ax square plus 2hx5 plus by square equals to 0, it represents a pair of straight lines passing through origin, or the point of intersection of these lines is origin. Now if suppose one line, the pair of lines passing through origin or point of intersection of these lines origin. If suppose one line slope is m1, second line slope m2, or m1 and m2 are slopes of these lines. Now one straight line equation is y equals to m1x and the second line is y equals to m2x. Y equals m1x and y equals m2x are equations of these lines. Now the combined equation of these two lines, y minus m1x into y minus m2x equals to 0. Now further simplifying, we get m1 m2 x square minus of m1 plus m2 into xy plus y square equals to 0. Just multiplying these two equations, we get m1 m2 x square minus of m1 plus m2 xy plus y square equals to 0. Now but in this equation the coefficient of y square is 1. Now but in the equation ax square plus 2hx5 plus by square equals to 0, the coefficient of y square is b. The complete equation divided by b, we get a by b into x square plus 2h by b into xy plus y square equals to 0. Now equating the coefficients of x square and xy, we get now sum of slopes of the pair of lines m1 plus m2 equals to minus 2h by b, comma product of slopes m1 m2 equals to a by b. Product of slopes equals to m1 m2, that equals to a by b. And difference of slopes m1 minus m2 equals to square root of m1 plus m2 whole square minus 4 m1 m2. Now a minus b equals to square root of a plus b whole square minus 4ab, but that equals to square root of m1 plus m2 whole square. But here sum of slopes m1 plus m2 equals to minus 2h by b, m1 plus m2 whole square equals to 4h square by b square minus 4 into product of slopes equals to a by b. Now by taking LCM, we get square root of 4h square minus ab 4ab by b. Now that equals to 2 into square root of h square minus ab by B. Now difference of slopes equals to 2 into square root of h square minus AB by mod B. That sum of slopes equals to minus 2h by B, product of slopes equals to A by B, and difference of slopes equals to 2 into square root of h square minus AB by mod B. Next, if suppose the slope of one line of the pair of lines ax square plus 2hxy plus by square equals to 0 is k times to other, slope of one line of the pair of lines is k times to other. Now require the condition. If suppose slope of one line consider m1, then slope of the second line m2 equals to km1, because one line slope is k times to other. Now sum of slopes m1 plus km1, but sum of slopes of the pair of lines equals to minus 2h by b. We get 1 plus k into m1 equals to minus 2h by b. Now product of slopes m1 into km1, but that equals to a by b. Product of slopes equals to a by b. Now k into m1 into m1 square, but from this equation we get the value of m1 equals to minus 2h by b into 1 plus k. Now k square m1 square equals to 4h square by 1 plus k whole square b square, that equals to a by b, 1b get cancel. Now we get 4k h square equals to 1 plus k whole square into ab. If slope of one line of the pair of lines ax square plus 2hxy plus by square equals to 0 is k times to other, then the required condition 4k h square equals to 1 plus k whole square into ab, Similarly, we get number of formulas in this. Now we discuss the problems. The separate equations of the lines 6x square plus 5xy minus 6y square equals to 0. The separate equations of the lines 6x square plus 5xy minus 6y square equals to 0. Just to resolving factors of the equation, we get separate equations. Now 6x square plus 5xy can be written as 9xy minus 4xy minus 6y square equals to 0. In first two terms 3x taken common, we get 2x plus 3y. In remaining two terms minus 2y common, 2x plus 3y equals to 0. Now 2x plus 3y common in both, we get 2x plus 3y into 3x minus 2y equals to 0. Therefore, separate equations of the lines 2x plus 3y equals to 0, another line 3x minus 2y equals to 0. The required equations are 2x plus 3y equals to 0 and 3x minus 2y equals to 0. Then second option is the correct. Second option. The range of A, so that a square x square plus 2xy plus 4y square equals to 0. A square x square plus 2xy plus 4y square equals to 0 represents distinct lines. Means two separate lines, but the equation second degree homogeneous equation, it passes through origin. Now two distinct equations, then compulsory, if suppose the pair of lines ax square plus 2hxy plus by square equals to 0 represents two distinct lines or two separate lines, then compulsory the condition h square minus ab must be greater than 0. H square minus ab greater than 0, the equation represents two distinct lines. If suppose the h square minus ab equals to 0, the two lines are coincident lines or only one line, coincident lines. If suppose E equals to 0, the equation represents two real coincident lines. If h square minus ab less than 0 or negative value, then the two lines are imaginary lines. The two lines are imaginary. Now, given the equation represents two distinct lines. Two distinct lines means real lines. Now, the condition is h square minus ab must be greater than 0. H square minus ab greater than 0. Now, here the value of h equals to 1 because 2h equals to 2, equating coefficients 2h equals to 2, h equals to 1, 1 square equals to 1 minus ab. Now, a nothing but coefficient of x square, b nothing but coefficient of y square. Now, a square into 4, 4a square greater than 0. Now, 4a square minus 1 less than 0. Now, here minus common, we get 4a square minus 1 less than 0. Now, factors of 4a square minus 1 is 2a minus 1 into 2a plus 1 less than 0. Now, if x minus alpha into x minus beta less than 0, the value of x must be lies between alpha and beta. Now, here the value of a lies between minus 1 by 2 and 1 by 2 or minus 1 by 2 less than a less than 1 by 2. Minus 1 by 2 less than a less than 1 by 2. Third option. The difference of slopes of the lines 3x square minus 4xy plus y square equals to 0. The difference of slopes mod of m1 minus m2 equals to 2 into square root of h square minus ab by mod b. The difference of slopes of the pair of lines equals to 2 into square root of h square minus ab by mod b. Now, that equals to 2 into square root of, here the value of h, half of the coefficient of xy, that equals to 4, h square equals to 4, h equals to minus 2, h square equals to 4, minus ab, here a equals to 3, b coefficient of y square 1, 3 into 1, 3 by mod b, coefficient of y square 1, or that equals to 2. Option is second option. The difference of slopes of the lines represented by x square into sec into square theta minus sin square theta minus 2xy tan theta plus y square sin square theta equals to 0 plus y square sin square theta equals to 0. Similar problem. Now, the difference of slopes equals to 2 into square root of h square minus ab by mod b. Now, that equals to 2 into square root of h equals to half of the coefficient of xy. Half of the coefficient of xy is minus tan theta. Minus tan theta. Now, h square equals to minus tan theta whole square, that is nothing but tan square theta minus ab. Here a equals to sec into square theta minus sin square theta. B equals to sin square theta. Now, sec into square theta minus sin square theta into sin square theta by b. B equals to sin square theta, or that equals to 2 into square root of tan square theta minus sec into square theta into sin square theta. Sec into square theta into sin square theta, that equals to tan square theta. Next, minus into minus plus sin square theta into sin square theta, sin to the power of 4 theta whole by sin square theta. Now, plus tan square theta minus tan square theta get cancel, or that equals to 2 into square root of sin to the power of 4 theta equals to sin square theta by sin square theta. Sin square theta also get cancel, equals to 2. Now, answer is 2. Now, second option. The combined equation of the pair of straight lines passing through origin and inclined at an angles 30 degrees and 60 degrees, 30 degrees and 60 degrees with x-axis, If suppose x-axis, y-axis, origin, required equations of the straight lines passing through origin and one line inclined an angle 30 degrees, second line inclined an angle 60 degrees with x-axis. Now, a straight line inclined an angle theta with x-axis in the positive direction, then its slope equals to tan theta. Now, slope of the first line equals to m1 equals to tan 30 degrees, or that equals to 1 by root 3. Similarly, slope of the second line equals to tan 60, that equals to root 3. One line slope 1 by root 3, second line slope root 3. Now, the equations of the lines y equals to mx, because passing through origin with slope m, y equals to mx. Now, equation of the first line is y equals to 1 by root 3 into x, otherwise root 3y minus x equals to 0. Similarly, the second equation y equals to root 3x or y minus root 3x equals to 0. Now, these are separate lines, but required combined equation of the two lines, combined equation of two lines. Just multiplying together, we get a combined equation. Now, root 3y minus x into y minus root 3x equals to 0. Now, multiplying together, we get root 3y into y, root 3y square, root 3y into root 3x, that equals to minus 3xy, next minus xy, minus x into minus root 3x, minus into minus plus root 3x square equals to 0. Otherwise, root 3 into x square plus y square minus 4xy equals to 0. Now, it is the combined equation of the pair of lines, then first option is correct. Root 3 into x square plus y square equals to 4xy. The slope of one line is twice slope of other line of the pair of lines ax square plus 2hxy plus by square equals to 0. Then 8h square equals to 8h square equals to. Now, consider one line slope m, then second line slope is 2m, because slope of one line, given slope of one line is twice the slope of other. Consider one line slope m, second line slope 2m. Now, sum of slopes equals to minus 2h by b, minus 2h by b. Now, 3m equals to minus 2h by b. Similarly, product of slopes m into 2m, that equals to a by b. Product of slopes m into 2m equals to a by b. Now, 2m square equals to a by b, but the value of m from this equation, m equals to minus 2h by 3b. By substituting, we get 4h square by 9b square. Now, m square equals to, here the value of m equals to minus 2h by 3b, then m square equals to 4h square by 9b square, that equals to a by b. 1b cancel. Now, 2 into 4h square, 8h square equals to, by cross multiplication, we get 9ab. Now, 8h square equals to 9ab. Third option is the correct. The sum of slopes of the pair of lines given by x square plus 2cxy plus y square equals to 0 is 8 times their product, then c has the value, require the value of c. Now, sum of slopes of the given pair of lines is 8 times to product of slopes of the given pair of lines, that is given condition. Require the value of c, If suppose slopes are m1, m2, then sum of slopes equals to minus 2h by b. Now, here minus 2h minus 2c, but b equals to 1. Next, product of slopes m1, m2 equals to a by b, that equals to, here the value of a nothing but coefficient of x square, b coefficient of y square, a by b equals to 1. Now, product of slopes equals to 1, sum of slopes equals to minus 2c. Now, sum of slopes equals to minus 2c, sum of slopes equals to, the given condition, sum of slopes equals to 8 times 2 product of slopes. 8 times 2 product of slopes. But sum of slopes equals to minus 2c, that equals to 8 into product of slopes 1. Then c equals to minus 4. The value of c equals to minus 4. Then third option is the correct. The angle between the pair of lines y square cos square theta minus xy cos square theta plus x square into sin square theta minus 1, sin square theta minus 1 equals to 0. If suppose the pair of lines equation ax square plus 2hxy plus by square equals to 0. If angle between these two lines is theta, angle between the pair of lines ax square plus 2hxy plus by square equals to 0 is theta, then cos theta formula a plus b by square root of a minus b whole square plus 4h square. If angle between the pair of lines ax square plus 2hxy plus by square equals to 0 is theta, then cos theta equals to a plus b by square root of a minus b whole square plus 4h square. If theta equals to 90 degrees, if theta equals to 90, cos 90 0, cos 90 0, then by cross multiplication we get a plus b equals to 0, a plus b equals to 0. Now here a nothing but coefficient of x square, b coefficient of y square. If sum of coefficients of x square and y square, sum of coefficients of x square and y square is 0, then angle between the pair of lines is 90 degrees. Angle between the pair of lines 90 degrees. Now here in given equation coefficient of y square is cos square theta or b equals to cos square theta. Coefficient of x square a equals to sin square theta minus 1. Now a plus b, cos square theta plus sin square theta minus 1. Now but cos square theta plus sin square theta is 1, 1 minus 1 0. Now sum of coefficients of x square and y square equals to 0, then angle between the lines is 90 degrees. Fourth option. The pair of lines given by x square plus y square into sin square alpha equals to x cos alpha minus y sin alpha whole square are perpendicular to each other, then alpha equals to. Now the given pair of lines perpendicular to each other required the value of alpha, required the value of alpha. Now angle between the pair of lines is 90 degrees, then the coefficient of x square plus coefficient of y square equals to 0. Now a plus b equals to 0. Coefficient of x square plus coefficient of y square equals to 0. Now coefficient of x square in the equation sin x square into sin square alpha, sin square alpha. In right side also we get x square coefficient, x square into cos square alpha, by taking left side minus cos square alpha. Now a equals to, or coefficient of x square equals to sin square alpha minus cos square alpha, sin square alpha minus cos square alpha, plus coefficient of y square b equals to, now coefficient of y square in left side is sin square alpha. Now in right side also sin square alpha, by taking left side minus sin square alpha equals to 0. Now angle between the pair of lines 90 degrees, or given pair of lines are perpendicular to each other, then a plus b equals to 0. Coefficient of x square plus coefficient of y square equals to 0. Now here plus sin square alpha minus sin square alpha get cancelled. Now sin square alpha minus cos square alpha equals to 0. Sin square alpha equals to cos square alpha, or tan square alpha equals to 1, tan alpha equals to 1, then alpha equals to pi by 4, 45 degrees. Alpha equals to pi by 4, third option. If theta is acute angle between the pair of lines x square plus 3xy minus 4y square equals to 0. Theta is acute angle between the pair of lines x square plus 3xy minus 4y square equals to 0. Now required sin theta, sin theta equals to, required the value of sin theta. Now if angle between the pair of lines is theta, then first cos theta equals to a plus b by square root of a minus b whole square plus 4h square. Tan theta equals to 2 into square root of h square minus ab by a plus b, and sin theta equals to 2 into square root of h square minus ab by square root of a minus b whole square plus 4h square. If angle between the pair of lines ax square plus 2hx5 plus by square equals to 0 is theta, cos theta equals to a plus b by square root of a minus b whole square plus 4h square. Tan theta equals to 2 into square root of h square minus ab by a plus b, and sin theta equals to 2 into square root of h square minus ab by square root of a minus b whole square plus 4h square. But here in problem required the value of sin theta equals to, now that equals to 2 into square root of h square, h nothing but half of the coefficient of xy, half of the coefficient of xy. Here 2h equals to 3, h equals to 3 by 2. Now h square equals to 9 by 4 minus ab, minus of minus plus 4 by square root of a minus b whole square, a1 b minus 4, a minus b 1 minus of minus plus 4, that equals 1 plus 4 5, 5 square 25 plus 4h square 9. Here 2h equals to 3, 4h square equals to 9. Now that equals to 2 into, by taking LCM we get square root of 9 plus 16 by 4 by root 34. Now square root of 4 is 2, 2 get cancel, 9 plus 16 25, root 25 equals to 5, 5 by root 34. Now the value of sin theta equals to 5 by root 34, third option is the correct. The equation of the pair of lines passing through the point minus 2 comma 3 and parallel to the pair of lines x square plus 4xy plus y square equals to 0, x square plus 4xy plus y square equals to 0. If suppose the pair of lines equation ax square plus 2hxy plus by square equals to 0, point x1 y1. Now the equation of the pair of lines passing through x1 y1 and parallel to the pair of lines ax square plus 2hxy plus by square equals to 0 is a into x minus x1 whole square plus 2h into x minus x1 into y minus y1 plus b into y minus y1 whole square equals to 0. Means just at place of x equals to x minus x1, y equals to y minus y1, replacing we get equation of the pair of lines parallel to the given pair of lines and passing through given point. Now point x1 y1 nothing but minus 2 comma 3. Now x minus of minus plus 2 whole square plus 4 into x plus 2 into y minus 3 plus y minus 3 whole square equals to 0. Now further simplifying we get x square plus 4xy plus y square minus 8x plus 2y minus 11 equals to 0. Now second option, x square plus 4xy plus y square minus 8x plus 2y minus 11 equals to 0. The equation of pair of lines passing through origin and perpendicular to the pair of lines 5x square plus 3xy equals to 0. 5x square plus 3xy equals to 0. If suppose the given pair of lines passing through origin, because second degree homogeneous equation, if suppose the equation of the pair of lines ax square plus 2hxy plus by square equals to 0. Now one line consider L1 equals to 0, second line L2 equals to 0, both lines passing through origin. Now required equation of the pair of lines passing through origin and perpendicular to the pair of lines, means one line perpendicular to one of the line of the given pair of lines, second line perpendicular to second line of the given pair of lines. if suppose L1 dash, L2 dash, L1 dash equals to 0 perpendicular to L1 equals to 0, L2 dash equals to 0 is perpendicular to L2 equals to 0. Required equation, combined equation of the pair of lines passing through origin and perpendicular to the given pair of lines. Now, if suppose the equation of the pair of lines ax square plus 2hxy plus by square equals to 0, equation of the pair of lines passing through origin and perpendicular to this pair of lines bx square minus 2hxy plus by square equals to 0, a by square equals to 0, means just the coefficients of x and y, x square and y square interchange, and coefficient of xy sign will be changed. The sign of coefficient of xy sign changes. If suppose it is plus sign, we get minus, minus we get plus. But the given equation 5x square plus 3xy plus there is no y square term means 0 into y square equals to 0. Now, here a equals to 5, b equals to 0, 2h equals to 3. A equals to 5, b equals to 0, 2h equals to 3. Now, just to substituting we get 0x square minus 3xy plus 5y square equals to 0. Now, 5y square minus 3xy equals to 0 is the required equation of the pair of lines passing through origin and perpendicular to given pair of lines. Then option is 3. 3xy minus 5y square equals to 0. The product of perpendiculars from minus 1 comma 2 to the pair of lines 2x square minus 5xy plus 2y square equals to 0. Require the product of perpendicular distances from minus 1 comma 2 to the pair of lines. Now, if suppose point x1 y1, point is x1 y1, equation of the pair of lines ax square plus 2hxy plus by square equals to 0. Now, the product of perpendicular distances from x1 y1 to the pair of lines equals to ax1 square plus 2hx1 y1 plus by1 square by square root of a minus b whole square plus 4h square. Just in numerator substituting the point in the given equation, by denominator square root of a minus b whole square plus 4h square. Now, minus 1 comma 2 substituting in the given equation, we get 2 into minus 1 whole square 2 minus 5 into minus 1 into 2 plus 10 plus 2 into 2 square 8 by square root of a minus b whole square, a minus b 0 plus 4h square, 2h equals to minus 5, 4h square equals to 25, that equals to 2 plus 10 plus 8, that equals to 20 by root 25 5, that equals to 4. Now, first option is the correct. The area of the triangle formed by the lines 2x minus y minus 6 equals to 0 and 3x square minus 4xy plus y square equals to 0 plus y square equals to 0. If suppose the given lines some Lx plus My plus n equals to 0 and ax square plus 2hxy plus by square equals to 0, means one is linear equation, it is only one straight line, other second degree homogeneous equation. Now, passing through origin, the pair of lines equation passing through origin and the line some Lx plus My plus n equals to 0. Now, the area of the triangle formed by the three lines, area of the triangle formed by the three lines is required. Now, that equals to n square into square root of h square minus ab by am square minus 2h lm plus bl square mod square units. The area of the triangle formed by the lines Lx plus My plus n equals to 0 and ax square plus 2hxy plus by square equals to 0 is n square into square root of h square minus ab by m square minus 2hlm plus bl square. Now, in given equation, n nothing but minus 6, n square 36 into square root of h square. Here h half of the coefficient of xy minus 2, h square nothing but 4 minus ab minus 3 into 1 minus 3 by am square, the value of a, the coefficient of x square 3 into m square, m equals to minus 1 whole square 1, 3 into 1 3 minus 2h lm. Now 2h equals to minus 4 minus 2h equals to 4 lm, L2 m equals to minus 1, we get 2 into minus 4 minus 8 plus bl square, b equals to 1, l square, l is 2, now l square equals to 4, or that equals to 36 into square root of 4 minus 3 1 by 3 plus 4 7 minus 1 modulus, then we get 36 square units. 36 square units, third option. The sides of a triangle are ax square plus 2hxy plus by square equals to 0 and y equals to x plus c, y equals to x plus c. Then its area, required area of the triangle. Now similar to previous problem, area of the triangle equals to n square into square root of h square minus ab by m square minus 2hlm plus bl square, mod square units. Now in given equation of the line x minus y plus c equals to 0, suppose taking y right side, we get x minus y plus c equals to 0. Yet the value of n is c. Now n square, c square into square root of h square minus ab, same as it is, h square minus ab by am square. Yet the value of m nothing but coefficient of y in the equation of the straight line. Now m equals to minus 1, m square equals to 1. Now am square equals to a minus 2hlm minus 2h into l equals to 1, m equals to minus 1. Then we get minus of minus plus 2h plus bl square b. Now c square into square root of h square minus ab by a plus 2h plus b. Now first option is the correct. The equation of the bisectors of the angle between the lines 2x square minus 3xy plus y square equals to 0. Require the equation of pair of angle bisectors of the given pair of lines. If suppose the given pair of lines, their point of intersection is origin. Now angles between the given pair of lines are two. One is acute angle, other is obtuse angle. Now required combined equation of angular bisectors, of the pair of lines. If suppose the given pair of lines equation ax square plus 2hxy plus by square equals to 0, then equation of pair of angle bisectors, of the pair of lines ax square plus 2hxy plus by square equals to 0 is h into x square minus y square minus a minus b into xy equals to 0. The equation of pair of angle bisectors of the pair of lines ax square plus 2hxy plus by square equals to 0 is h into x square minus y square minus a minus b into xy equals to 0. Now in given problem h equals to minus 3, 2h equals to minus 3, h equals to minus 3 by 2, minus 3 by 2 into x square minus y square minus a minus b, a equals to 2, b equals to 1, 2 minus 1 into xy equals to 0. Now minus 3 by 2 into x square minus y square minus xy equals to 0. By taking LCM as 2, minus 3 into x square minus y square minus 2xy equals to 0. Now minus taken common, we get 3x square plus 2xy minus 3y square equals to 0. The required equation of pair of angle bisectors of the given pair of lines is 3x square plus 2xy minus 3y square equals to 0. Fourth option.